Let's begin with the basic rectangle, and we'll say that the width of the rectangle is x and the height of the rectangle is y. I'm going to split the rectangle in two by using a horizontal bisector. The bisector splits the rectangle into two equal parts, and so the top and bottom are exactly the same size, which means that their width is still x, but the height of the new rectangles is now y over 2. Now I'm going to split both rectangles in two by using a vertical bisector. The bisector splits both rectangles into two equal parts, and so now the resulting width of each side is x over 2. Now we have four small rectangles, and you should be able to see that the rectangles are of equal size. They all have the width x over 2 and the height y over 2. Because one bisector is horizontal and the other one is vertical, they must intersect at 90 degrees. So let's put in the right angle. Obviously these two lines are perpendicular, so all of the angles at the intersect must be 90 degrees. I'm now going to divide each of these rectangles in two with a diagonal line. This results in the four rectangles being split into two triangles. You should be able to see that the height of each triangle is y over 2, which is the height of the original smaller rectangle, and the base of each triangle is x over 2, which is the base or the width of the original rectangle, and that applies to all of the triangles. So we now have 8 equally sized triangles, each one having the base of x over 2 and the height of y over 2. We can use these values to calculate the area of each of the individual triangles. We know that the area of a triangle is given by the half base times height, and we can rewrite the base and height in terms of the x and y values, so that must be equal to 1 over 2 times the base. Well, the base is x over 2, so that's x over 2, and the height is y over 2, and if we simplify that, that's going to give us x times y over 8. Since we know that all of the triangles are the same size, I'm just going to keep two of these x over 2 and y over 2 values to give us more room for calculations. Remember also that the width of the large rectangle was x and its height was y. Therefore, the rectangle area must be equal to x times y. Now we can think of these triangles in terms of their position. We have four external triangles, and then there are four internal triangles. As you can see, the four internal triangles form a shape. The area of that shape must be 4 times the area of one triangle, which is 4 times x times y over 8. Well, that equals x times y over 2. Now, if this shape is a rhombus, that proves that the area of a rhombus is x times y over 2. We just need to confirm that the four internal triangles form a rhombus. Well, that's not very difficult to do, because first of all you can see that this is a parallelogram, but it's just sitting on one of its corners. But a parallelogram is only a rhombus if all four of its sides are of equal length. But all these edges must be of equal length, because each edge is just a diagonal of one of the smaller rectangles, and we know that these smaller rectangles are exactly the same size, so these four diagonals must be the same length. And if you're still not sure that this is a rhombus, it has one more property, which is something that I covered in a recent proof video, which showed that diagonals in a rhombus, or the internal lines of a rhombus, intersect at 90 degrees. Well, we saw earlier that these two lines intersect at 90 degrees, but they are the internal lines of this parallelogram, so this must be a rhombus, and therefore the area of the rhombus can be given by the formula x times y over 2, where x and y are the internal lines.